Chapter 8, Right Triangles. Today we're going to cover Section 8.7, Applications of Right Triangle Trigonometry. Your class opener. Find the value of x to the nearest integer. Today's objective will be to solve right triangle problems by correct selection and use of the tangent, sine, and cosine ratios. Before we get into those, there's something new that we have to talk about. It's an angle of elevation, which is the angle above the horizontal created by the line of sight. So for this, I imagine if you were looking at something, so here's my crude eyeball. Imagine instead of looking straight across horizontally, if you had to look up at, say, a bird flying in the sky, this angle that's created right here would be the angle of elevation. So instead of horizontal, if you had to look up at a 30-degree angle to see something, the angle of elevation would be 30 degrees. Okay. Angle of depression is similar. It's the angle created by the line of sight, which is below the horizontal. So similar type of thing. Again, here's my crude eyeball. Imagine instead of looking straight ahead, if you looked at something down on the ground. Well, if you looked down at the ground, you're not looking straight across, and some angle would be formed. Let's say you were looking and it was a 20-degree angle. That would be an angle of depression, the angle that you're looking down. Now, interestingly enough, imagine if you were standing over here and your friend was standing on the top of a hill and you were looking at each other. Well, if you're down at the ground, you're going to have an angle of elevation because you're looking up, and let's say this happens to be 30 degrees. Well, if your friend is looking at you, instead of looking straight across, he's looking down, and his angle of depression is also going to happen to be 30 degrees. And one reason I know they happen to be the same is if instead of looking horizontal, both of those would be parallel lines. So alternate interior angles would have to be the same. So if two people are looking at each other, the angle of depression and the angle of elevation between those two are the same exact value. Number 1, when the sun's angle of elevation is 57 degrees, a building casts a shadow 21 meters long. How high is the building? So I'm going to draw a crude picture. So if here's my building, and down here on the ground is the shadow for the building. Here's my angle of elevation. The angle of elevation is 57 degrees. The shadow down on the ground is 21 meters. And I'm looking for how high the building is. Well, I think of my trig function, so I remember SOHCAHTOA. And I look at my problem. I have a 57-degree angle, and then I have these other two values. Well, from the 57, x happens to be opposite. The 21 meters is adjacent. And if I'm dealing with opposite and adjacent, I'm going to have the tangent function. So let's set up a tangent function. Tangent of 57 degrees equals opposite x over adjacent 21. And I'm just going to cross multiply. So let's see what the tangent of 57 is. 1.5399. And if I cross multiply that, I'm going to get that. And I think for a distance, let's round to the nearest tenth on this, I would get 32.3. So the height of the building would be 32.3 meters. Number 7, Martha is 180 centimeters tall and her daughter Heidi is just 90 centimeters tall. Who casts the longer shadow? Martha when the sun is 70 degrees above the horizon, or Heidi when the sun is 35 degrees above the horizon? So, two people. So here's going to be Martha. Martha is 180 centimeters tall. So drawing my picture. So she's 180. And the sun is 70 degrees above the horizon for her. So I have a not drawn to scale, 70 degrees. Heidi is only 90 centimeters tall. And for her, the angle is 35 degrees. And I want to know which person has the longer shadow. So trying to find X for both of these. And I notice for each of these, my angle, I have the opposite and the adjacent. For my angle, I have the opposite and the adjacent. So both of these are going to be tangent problems. So over on the left, I'm going to get tangent of 70 degrees equals opposite over adjacent, 180 over x. And I'm also going to get a tangent for the one on the right. The tangent of a 35 degree angle equals opposite over adjacent, which is 90 over x. So now it's really just saying which one of these is going to give me the bigger shadow. So let's do the one on the left. Tangent of 70, what's that as a decimal? And I get 2.7478. And if I cross multiply, I get 2.7478x equals 180. So I need to divide each side by 2.7478. So let's see, I'm taking 180, dividing by 2.7478, and getting an answer, we'll round to the nearest tenth, 65.5. So I can come up back here, her shadow then is 65.5 centimeters. And now figuring out the shadow for Heidi. So over here I need to figure out what the tangent of 35 is, which is 0.7002. Cross multiplying over here, 0.7002x equals 90. Divide by 0.7002. So taking my 90 and dividing by 0.7002, and I get 128.5. So our questions was, who has the longer shadow and by how much? So I think we can easily see here that Heidi is going to have the longer shadow, and now it's just by how much. So what's the difference between the two values? So again, you can just grab your calculator if you want to. 128.5, subtract 65.5, and it's a difference of 63. So I'll just write over here for Heidi then that it's 63 centimeters more. And your closure. Describe how you remember the difference between the different trigonometric functions.